So as I told you before, all the questions gonna be the similar in similar idea. So the next question is what is the total charge, and how we sign this total charge with the letter BQ, right? And let's add tot, which means total of what? Right now it's gonna be different, a little bit more challenging. It's gonna be of a plate. So let's draw a plate, how a plate look like. So what I need for a plate, actually I need only radius. If it's a perfect circle. So R is the radius, and let's do, it's on my table. So this is the Cartesian, right, coordinate. I have X, Y, so, and this is also a top view. I look at a plate like this, right? So I have here maybe a knife, right, and a fork, and some fork. So I eating dinner or something. So this is my plate. And they tell me it's not a regular plate. This plate actually been charged with the electrical charge. So how is the charge distributed on this plate? So the charge is sigma. Let's do it here. Sigma. And the unit of sigma is charge, coulomb. This is the unit of charge, coulomb, per meter squared. Which means on every meter squared, I have this amount of charge. That's the idea. So the charge density in this specific problem is some constant, sigma naught, over r, another constant which is the radius, and multiply by r. So you can think about that, this is like a linear relationship, which means as I go far away from the center, I get more and more charge. Okay, that's how I want you to think about that. And if you remember from the previous questions, what we need to do, we want to find the total charge. How are we going to do it? We know that the total charge, right, Q, equal to what? To the sum of its part. To the sum, integral, its part, dq, right? So what we need to do, remember that I told you this abbreviation to do, first of all we need to divide. We need to divide this plate into small chunks. Here it is. For example, I can build all this sphere for small chunks. So I want to find what is this chunk, how I can say these chunks in the language of mathematics. So small chunks, divide, and then we're gonna obtain this integral. Obtain this integral. Perfect. We know what we are going to do. So how am I gonna divide this thing? So when I'm looking at a circle, you know I can use the Cartesian thing, which I like to think about it like a chess game. Remember the scene in Harry Potter when Ron Weasley said go to E4, which means go to E4, which means go some horizontal direction and vertical direction. So this is exactly what's going on. So instead of that, when we're talking about some circles, sometimes it's better to use polar coordinate. And polar coordinate are acting like a cannon. What do I mean by that? Think about that I have some gunpowder that I put inside. I want to shoot. So if I put a lot of gunpowder, I actually play with this coordinate, which is r, the distance. If I put a lot, I'm gonna go far away. If I'm gonna put small, I'm gonna be close to the cannon, which is in the middle. So I have r. And also I can decide where I'm gonna shoot. I'm gonna shoot this way, or maybe to change direction and shoot this way. And this is theta. So I have also r and also theta. And if I want, and now let's try to use this r and theta to describe the chunks of this plate. So allow me just to clean it a little bit. So think about it that r, here it is. This is r coordinate. I actually draw a circle, right? And this reminds me like when you cut a salad. When you have a salad, you put cucumber, tomato, and then you have the onion. So when you cut onion, you have these circles. So actually I'll divide space into many circles. And if you remember in the previous question, how we said small movement, small change in x, we call it dx. And now a small movement in r, we're gonna call it dr. Yeah, we're not that creative in physics and math, so I'm gonna call a small piece, a small movement. Let's do this. This is my chunk. Okay, here, let's put it here. So this is the chunk. Okay, so small movement in R is actually, this one is dr. Here it is, dr. But this is not enough to describe these chunks, because if I'm gonna sum up lines, line after line after line, I would not get anything. I need also to find what is this thing. This, here it is. This line is equal to, in order to have some area. So let's get rid of this, which is unnecessary. So this part is actually a movement in theta, right? So here I move from here and here some angle. Which angle it is? It's d theta, but it's not enough to say d theta. It's d theta multiplied by r. Why so? Because we're talking about radians. This is the unit of radians. So if we're gonna, for example, I don't know if you know it, if it's trivial, but I always explain it because when I was a student, undergraduate student, it was a little bit hard for me to grasp it, and I only realized that along the way. But if you have some angle, for example alpha, and alpha is given in radians, so, and if you want to know what is the circumference of this part, you just need to know what is the distance from here, which, for example, here it's r, let's call it big R, just for the case. So this circumference is r multiplied by alpha. This is what genius about the radians coordinates, okay? So that's the reason how we found out about the radians. We're gonna go along. So if you have some circle, right, and you want to know his circumference, maybe you already know that the circumference is 2 pi r, but actually the idea is that if you have a circle, it's really easy to measure this distance, which is the diameter, 2r, right? And they just said, let's call this angle of the full cycle, right, 2 pi. This is the reason the circumference is 2 pi multiplied by r. This is the distance of this angle. And if I want to know some fraction of it, for example, let's put here, here and here, some alpha, and alpha is a part, it's a part of it, so we know that this part is a part of the whole cycle. This part is only alpha multiplied by r, right? If I want all the circle, it's going to be 2 pi multiplied by r. But this is the general idea of radians. So you can go and figure out a little bit more in other videos, but in this one video I want to talk about that this part is dr, and this part is d theta dr. You see? This is the chunk, and with this chunk, if we're going to sum them all up, I'm going to get my circle, and this is really small, really small. So let's continue. I'm going to clean this off, so we're gonna have some space. So, and here you see this is actually all the theta, right? But this part is some small movement. It's only d theta. Okay, that's the idea. So I know this area of this surface, right? Let's call it ds because it's a small surface. ds is equal to what? To dr multiplied by d theta r, which this is the way to calculate some area, right? This height or multiplied by the base, so you have this size. And what we want to find, dq. How much charge I have on this small chunk. So this small chunk actually have dq equal to what? To sigma r, right? My charge density multiplied by this one, ds. So it's dr d theta multiplied by r, and this equal to, let's put it here, so sigma 0 r, and I have here r squared, perfect, dr d theta, and this is my dq. This is perfect. I just found dq, which means I finished the idea of dividing into small chunks, to small pieces. And now to find q total, what I need to do, I need to obtain this integral, right? So let's do it. So Q total is equal to the integral of what? Of this, of dq. So this dq is sigma 0 over r multiplied by r squared dr d theta. And then I realized that I'm inside a big problem, because I don't have an integral only with dr, which dr I know. Dr is to start running from here, the plate exists in the 0, and finish up at the end, the edge of the plate, which I give it to you, which is r. But then I have another thing, which is d theta. So what do I do when I see another variable that change? So what I'm gonna do is just add another integral. Because yes, it's true, I'm using r to describe the plate, but I need another integral to run with theta, which is from 0 to 2 pi. Why from 0 to 2 pi? You must use radians, right? We talked about it. We use this phenomena to get d theta. And the second thing is that you need to understand what is the smallest angle that you have. The smallest angle that I have is 0. And I have until I finish. I have 2 pi. If I would have, for example, one circle and then another maybe 2 plates, it's going to be 4 pi. But right now I have only from 0 to 2 pi. So I finish that one. So what I need to do is actually solve the integral as I did before. I'm going to take the constant outside, I don't need them, sigma 0 r. And you can look that if I'm going to do the integral using theta, sigma 0 over r, using theta, actually there's nothing here using theta, right? Maybe in your homework you're going to see it differently. You're going to see some sinus of theta, and the integral going to impact that. But right now I don't give anything, it's a constant if you're thinking about it as a theta. So you just can multiply by 2 pi. And now I can solve the integral, which is r using r, right? So it's a r to the third over 3 from 0 to r, right? So this is gonna be r. So this is equal to 0 to pi r 3 r to the 3. You can go with this one, and this is equal to sigma 0 2 pi r to the square over 3. So this is the solution for that question. And another thing that I want to ask, if, and when I say if, it means that it's not true, it's just an example for something, if it would happening. So look, actually let's leave this here, it's okay for me, d theta. So let's get rid of this. If my plate was a Pac-Man, if my plate was a Pac-Man, okay? How the solution would change? What is Q total now? What is Q total right now? That's what I want to find out. What do I mean by say it's a Pac-Man? So I want you to take this plate, let's clean it a little bit. Let's get it. So my plate right now is a Pac-Man, which means this is how it's look like. Okay? You have this part, you can draw an eye. This is Pac-Man, right? So when I run the integral, remember that I counted pieces like this one, that here. But right now, this piece is not valid. I don't care about this kind of pieces. I care only about pieces that in this side of the Pac-Man. You see? Not this part. So how the solution would change? So this is a classic thing to do on exam, you know, they give you the easy thing in class to do, and in exam a little bit more challenging thing, more thinking stuff. So think about it, that what changed here? I don't care about angles from 0 until pi over 2, right? So the only thing that need to change to solve the next section is actually changing 0 to what? To pi over 2. You see it? This is pi over 2. I don't care about these pieces of this division, right? So I don't need this one. If I'm going to sum them up, I would not get a Pac-Man. I would get a normal plate. So this is how you're going to solve it. And I want to give you a similar question, which is if someone would shoot inside my plate, in the middle, So how the solution gonna change? So let's write it down. So if someone would shoot in the middle of the plate, what is Q total? Q total equal to question mark. So let's draw again our plates. So if this is the plate and somebody shoot inside it, and now I have a hole inside, right? This is only the plate right now. I don't have the middle. So let's call this A and maybe this B. So how the solution has changed. So this is also easy. Why? Because at the beginning I had chunks, small pieces that were in this hole. But now they are not relevant, they're not valid anymore. And the way to describe this is not valid anymore is to change the limits of the integral. This I'm gonna change it. Let's do it on purple. Somebody shoot in the middle. So I have this idea which is not relevant. What is not relevant? All these r distance. You see, it's not the angle, it's actually only r. So this is gonna be changed to A, and this needed to be changed to B, right? And let's make it even more sophisticated. If I have these two things happening alone, which mean that somebody in the exam give me this donut, which somebody took a bite from it, how I can solve it? I can say, oh, I know this kind of problem, I saw it in the tutorial, which means I have a circle, so we're gonna solve it like a circle, but in the limits I'm gonna put these two conditions. The first one is gonna be, don't count these angles, right? And the second thing would be, don't count these radius, they are not valid. So you can see how you can solve a really complicated figure by doing that, okay? So this is perfect. So right now we're gonna go to the next question, which is not plate, it's something else.